Now let's look at a couple of examples that illustrate how equational reasoning interacts with relational reasoning. The father of Quincy is Pat. Fathers are older than their children. Our job is to prove that Pat is older than Quincy. As usual, we start with our premises. The father of Quincy is Pat, and fathers are older than their children. First, we use universal elimination to instantiate our quantified sentence. The father of Quincy is older than Quincy. Next, we use equality elimination to replace father of Quincy with Pat, and thereby derive the conclusion that Pat is older than Quincy, the conclusion that we wanted. Here's a slightly more complicated example. We know that P of A is true, and we know that P of B is true. Suppose we also know that A equals C or B equals C, but we do not know which. Let's prove that despite this uncertainty, we still know that P of C is true. Premises to start: P of A, P of B, and the disjunction A equals C or B equals C. We start a new subproof with the assumption A equals C. From this assumption and our first premise, we can conclude that P of C must be true. Of course, we're not done yet, since we have proved the result only under the assumption that A equals C. We make this clear with the use of implication introduction to derive the sentence A equals C implies P of C. Now we start another subproof, this time with the assumption B equals C. As before, we derive P of C, and from this we derive the implication B equals C implies P of C. Finally, we use an OR elimination to combine our two partial results with our disjunction of equations to produce P of C at the top level.